So, and this was also one of the papers that you read for today. There seems to be this clustering of brain activity in parietal and prefrontal regions that's correlating with this conscious awareness of at least the visual objects and also other types of objects. So one of the hallmarks seems to be that there is this parietal and frontal areas. But as you can see also in this review, that you can also see that other areas, depending on what type of study you look at, will have activity when you have this conscious percept of visual objects. One of the most puzzling, but also most cited phenomena in the study of consciousness is the phenomenon of blindsight. And it's a phenomenon that has been reported a couple of times in the literature. And what you can see in these reports is that you have patients with lesions in the visual cortex, usually in the primary visual cortex, which are able to react to stimuli which they cannot perceive. So what you, for instance, do is that you take up some fingers and ask the subject, or the patient, how many fingers are here, and they say, I cannot see anything, if you present it in the right spot in the visual field. And then you force them to guess, and the strange thing is that they actually guess well above chance level. And that's of course puzzling, because how can they actually do that? And it seems that they in some way actually receive the information, but it's not consciously perceived. But if you're forced to guess, they are then able to do it correctly. However, Seki and colleague, they then had a patient suffering from such a lesion, and then they tried to sort of quantify their percept. And if you go through the literature on blindsight, it appears that there is a tendency that in the cases where subjects or patients were able to actually correctly report something, there might have been some type of residual vision present. So if you ask them, they might have seen, okay, there was maybe some feeling of me being able to see something, or which is possibly somewhat above the detection of the level where you are just completely guessing. So whether this phenomenon is truly something that's present if you really ask into details and not just ask, did you see it or did you not see it? It might be a more gradual phenomenon. So for instance, if you're in a situation where you have sort of a vague feeling that there was something and maybe try to guess the direction of a stimulus, you might be prone to actually say, okay, I didn't see anything, because you're pretty low your certainty of whether you saw it or not is pretty low, and you're not so confident in it. So you might be tempted to just say, okay, I didn't see anything. But another phenomenon that you can observe with these patients is that they are able to make motor reactions. For instance, they can post a letter in a letterbox like this, which has different angles, but they're not able to report which angle this mail box is located in. So they can actually do the correct motor response, but they're not able to report it consciously. We have tried to look at this phenomenon in the lab, and what we did was that we, instead of having patients with lesions in the visual cortex, we used the technique that you have all heard about with using transcranial magnetic stimulation over the primary visual cortex. So you can see a subject here sitting with a TMS stimulator over the visual cortex. And what we then did was that we presented a visual stimulus in the center here and asked the subjects to reach from this start button to the middle button. And then in some of the cases, there was a light either to the left or the right. And this task for the subject was then to correct the arm movement so that they, instead of hitting the middle button, they either hit the right or left button, depending on what signal that was presented to them. What we then did was that we used TMS over the visual cortex, so around 80 to 90 milliseconds after this signal, either to the right or left, was presented. And what we then were able to do was that we were able to actually blind the subjects. So here you can see how many correct reports that the different subjects had in the cases, or how many errors, no, how many correct responses. In black, without TMS, and then with TMS. So you could see that the reportability dropped when you had the TMS over the visual cortex. There was a single subject where it wasn't the case, but otherwise it was pretty consistent. What then was the more intriguing part was that actually in the cases where the subjects had reported that they had absolutely no sensation of the light, either to the left or the right, they were still better than chance at doing a correction towards the correct light, even though that they had absolutely no conscious perception of it. And what we did in this study was that we actually tried to be more specific than just saying yes or no, did you perceive it, but actually tried to grade it more fine. So they had a grading scale of 5 different ratings where they could report whether they saw it or not. And they were able, better than chance, to actually make corrections towards the light that they hadn't perceived. So even in the cases where there seems to be absolutely no conscious perception, you can still make these motor reactions to it towards the correct lights. So in that case, we used TMS as a way to actually degrade the percept of a visual stimulus. What you can also do is that you can use what's called visual masking. And the idea is that you can present a visual object. For instance, in this case, was a study where we had 3 different figures that we present for a very brief period of time, so up to 100 milliseconds. So at 33 and 50 and 83 and 100 milliseconds. And what you then do afterwards is that you present a visual mask that consists of all these figures. And when you present this afterwards, it becomes very difficult to actually see these stimuli. If you just present a visual stimulus alone without any mask afterwards, you can actually see visual stimuli that are very, very short. So in the first experiment here, the lights, they were presented for less than a millisecond, and you can still see a light that's presented for less than a millisecond if you don't present a mask afterwards. But if you present a mask, you degrade visibility tremendously. And this technique has been used also with faces, as we have seen in last time in these emotional faces. And you can also do it with letters and different other types of stimuli. So the idea is that you present one stimulus and then you have a second stimulus afterwards that serves as a mask and thereby degrades your visibility. And if you have to do studies where you use a computer screen where you have a fixed repetition rate for each frame on the computer rates, usually you have a frequency of maybe 60 or 75 hertz of the computer screen, well, then you have to use these visual masks in order to have stimuli that are so vague that you cannot really see them. Another example is this, where you present a target and then you have a stimulus around the target presented somewhat later, which serves as a mask. And what you can then do, actually, which is a bit funny, is that you can then, with TMS, demask the mask, so the stimulus here in the beginning actually becomes visible again. So you present a stimulus which normally with this mask is not visible, but then you remove the effect of this mask with TMS, and then you are actually able to see the target at the first hand. So you can use these maskings in various ways. What we did in one study was actually to look at the difference, or at least try and see if we could find brain activity that correlated more with a graded perceptual scale rather than this distinction between being consciously aware or unconsciously aware of something. So what we did was that we presented these three objects as you saw before, and then with this visual mask, and then we asked the subjects to rate on a subjective scale whether they had a clear percept or a vague percept or no percepts. And then we actually found this network again with the interparietal cortex, premotor cortex, and also more frontal, inferior frontal regions, and also some areas of the basal ganglia, where you actually had brain activity that gradually increased with the perceptual experience that you had. So if you ask these subjective questions, you can actually get some activity that seems to correlate with it. Of course, and I will come back to that later in the second discussion, there are of course some limitations with using